I'm Beckett. This is Lab 1, Constant Motion for Physics 2012. The purpose of this lab is to compare the experimental motion of a mass at constant velocity to a computational model of the same mass at constant velocity. In this lab, I recorded a video of a cart moving at constant velocity along a track and compared it to a glow script model of a point mass moving at constant velocity. So the fundamental physical principles that we need to use are the momentum principle, which acts as a velocity update formula, and the position update formula. The momentum principle is that F net is the derivative of momentum with respect to time, which means that is also mass times the derivative of velocity, which with respect to time, at speeds not approaching light speed. And so what that means in this context is that if the F net is 0, the dv dt is 0, which means velocity stays constant because there's no change in velocity. Position update formula, the final position equals the initial position plus the average times delta t, which means that if velocity stays constant, then the position will increase at a constant rate. In the experiment, my initial conditions: mass of the car 0.25 kilograms, initial velocity, which I calculated by taking delta x, the final x in the video minus the initial x in the video, and then final time in the video minus the initial time in the video, ended up being 4.34 meters per second. The initial position was 0.0500 with my coordinate system along the tape measure. So it starts at 50 cm on the tape measure. My system is the car, and my surroundings is everything that isn't the car, so the track, the air, the table, everything like that. Here is a video of my experiment. And you can see the cart moving at constant speed across the track. So my computational model used GlowScript starting from a base of the given Lab 1 code. It is a computational model of a point mass at constant velocity. And I made a few assumptions. 1, there's no net force in the object, and 2, mass doesn't change. No net force in the object means that there's no acceleration and velocity is constant. Mass changing would affect F net being the derivative of position with respect to time, and position is mv. So that would change like acceleration and mess up the whole thing. So I did assume that there was no net force, and there was no change in mass. Here's my code. My initial conditions are position as close to 0, as I could get it due to some tracker time step errors, and the velocity, the initial velocity is 4.34. The clock starts at 2.8 because that's where in the video my car crossed 50 cm. And then delta t is the same. And so my code just says while t is less than where my video ends, I calculate the net force, which is always 0 because the ball's moving, because the cart is moving at constant velocity. It's modeled as a ball in the GlowScript. And so I apply the position update formula to update the object's velocity with Fnet, and then update the object's position with velocity, and then I advance the clock t plus delta t. So this is my graph. The observed x is in blue, the predicted x is in green. The observed x is actually slightly larger than the predicted x, and it has a greater magnitude of slope, so it has a slightly higher velocity than I predicted. Some sources of error: the car and track have some friction. There's some air resistance. I messed up putting the video into tracker. The initial velocity is wrong, or there are external forces. If I were to flip the axes, the magnitude of velocity would not change, but the direction would. So the position would get more and more negative, but there would still be no external forces. So we assumed that net force equals 0, but we can determine some of the forces. Like, we know gravity exists, and we know normal force is present to balance out gravity, so the car actually stays on the table. But we don't know anything that's like making net force be 0 in a horizontal direction. Conclusion: my models were in GlowScript. I recorded the cart and low friction track. I compared the two graphs. My errors are probably due to either tracker or unaccounted forces.